Okay, hello. This is Unit 2, Day 1, Sections 3.1 and 3.2. We're solving one-step and two-step equations. So here's our video notes. Here's our learning targets. I can solve a linear equation. I can justify the reasonableness of a solution and explain the steps using proper mathematical vocabulary and within the constraints of the word problem. Okay, so let's get started. So, inverse. Operations are two operations that undo each other, such as addition and subtraction. They undo each other. When you perform the same inverse operation on each side of an equation, you produce an equivalent equation. Okay? So we're going to be solving equations. Equivalent equations are equations that have the same solution. So they might look a little different, but they're equivalent. And the objective of this whole unit right here, I'm going to write this right up here. So the objective of solving equations. So solving equations is to get x by itself. We want to get x by itself. That's our objective, okay, whenever we're solving. Okay, so let's start. Solve an equation using addition and or subtraction. So if I see this equation right here, x plus 7 equals 4. Let's try it. Maybe we can blow this up a little bit. There we go. So if we say x plus 7 equals 4, I have to solve that. So my inverse operation of addition is subtraction. So I want to subtract 7. Remember, I want to get x by itself. That's my goal. I'm going to subtract 7 from each side. Remember, sometimes you put a wall down, it's a scale. Whatever you do on one side, it has to be equal on the other side. We have to keep it balanced. Okay, so I'm going to undo that addition by subtracting. If I subtract on this side, I subtract on that side. 7 minus 7, that goes away, and I'm just left with x. That's what I want. 4 minus 7 is negative 3. Okay? So we have to get used to using those terms. I have to undo addition by subtraction. Okay? Let's try this one. So, x minus 12 equals 3. So I have to get x by itself. That's my objective. And I have to be balanced. So whatever I do on this side, I have to do on the other side. So I have a minus, 12 is being subtracted. So the inverse operation is addition. I'm going to add 12. If I add 12 on that side, I have to add 12 on this side. Makes this side go away. Negative 12 plus a positive 12 goes away. I'm left with x equals 3 plus 12 is 15. Okay? Remember, we got to keep balanced. So our inverse operations. If it was subtraction, inverse, how do I undo it with the inverse? I add. Alright, now there's a couple you tries. You guys got to try these. So try these. Stop the video if you have to, and then I'm going to go on. And then you can unpause it when you're done with those. So the next part is multiplication and division are also inverse operations. So multiplication and division are inverse of each other. So the multiplication property of equality can be used to solve equations using division, and the division property of equality can be used to solve equations using multiplication. All this means is multiplication and division are inverse. To undo multiplication, I use division. To undo division, I use multiplication. So, solve an equation using division and or multiplication. I want to get x by itself. Remember, whatever I do on this side, I have to do on that side to keep it balanced. So minus 6, negative 6 times x equals 48. So negative 6 is being multiplied by x. So to undo that, I'm going to divide by negative 6. I undo the multiplication with division. If I do it on that side, I do it on this side. Makes that negative 6 go away. Negative 6 divided by negative 6 is 1. So I'm left with a single x equals 48 divided by negative 6. Put it in your calculator, If you want, I can show you how to do that one. 48 divided by, we have to use the negative, whoops, we have to use the negative button down here, -6, and it equals -8. Okay, so let's look at B. X over 4 equals 5. I have to get x by itself. What's happening to the x? Well, it's a fraction, but it's really dividing. Whenever you see a fraction, it means division. So x is being divided by 4. So how do I do that? I'm going to multiply. So maybe I'll rewrite this down here. X over 4 equals 5. So I'm going to multiply this side by 4. If I multiply that side by 4, I'm going to multiply this side by 4. I have to keep balanced, remember. This 4 cancels, cross cancel. 4 on the top, 4 on the bottom, they cancel. I'm just left with x, which is what I want. Equals 5 times 4 is 20. And you could check these too. If you want to put 20 into that original equation and say 20 divided by 4, well, that's 5. That's what that equation is. Okay? So now, if you guys turn the page, I think you have some U-tries. You have a couple of U-tries you have to do. So try these. Pause the video. Try these. Okay, hopefully you tried those U-tries. And now, we're going to go on. The product. So the product of a number and its reciprocal is 1. Let's talk about what reciprocal is. Reciprocal is just flipping. So if I asked you what the reciprocal of 1/2 was, we flip that over. The reciprocal of 1/2 is 2 over 1. Okay? So this says, if I wanted to do an example, so let's say 2 over 3. If I multiply by the reciprocal, which is 3 over 2, I multiply straight across the top, I get 6 over 6, which is 1. That's why that works. Okay, you can isolate a variable with a fractional coefficient by multiplying each side of the equation by the reciprocal of the fraction. Let's do an example. Okay, we're going to solve this equation. So I'm going to rewrite this over here. -2/7 x equals 4. Okay? So I want to get x by itself. If there's a 1 in front of it, it's by itself. So I know that if I multiply this fraction by its reciprocal, it turns it to 1, just like we set it up here. So I'm going to multiply this side by a negative, 7 over 2. I just flipped the fraction, and I want to keep the negative in there too. Okay? So I multiply this side by a negative 7 over 2. And this negative can go inside. Okay? So look what happens over here. Negative and a negative, that turns positive. 7 on the top, 7 on the bottom cancels. 2 on the bottom, 2 on the top cancels. I'm left with x. Over here, we can do it a couple different ways. I can use my calculator and I can say 4 times, we'll use my fraction, hit enter, and I'm going to put 7 over 2. And I get 14. So that equals 14. So x equals 14. And you can double check by putting 14 back into there. And it will come out as 4. Over here we could have cross canceled also. I could have said 4 is like 4 over 1. Well, the 2 goes into 4 2 times. 2 goes into 2 1 time. So we multiply straight across the top now. 2 times 7 is 14. And there's 1 on the bottom. So we can do cross canceling also, but you can also use your calculator. Okay? Another U-try for you guys, so pause the video and try that. Alright, example 4. It says sometimes equations involve performing more than one operation before we can solve for the variable. So remember, the object is to get x by itself. But in this equation here, there's a couple things going on. So 5 is getting multiplied by x, or x is getting multiplied by 5, and then it's adding 9. We want to take care of addition and subtraction first. So since I want to undo that addition, I'm going to use the opposite operation, and I'm going to subtract 9. If I subtract 9 on that side, I subtract 9 on this side. So positive 9, negative 9 goes away. I'm left with 5x equals 24 minus 9 is 15. Okay? Still don't have x by itself. It's being multiplied by 5, so I'm going to divide by 5 on both sides. Remember, we want to keep that balanced. 5's cancel. I'm left with x. 15 divided by 5 is 3. And if you want to do a quick check, we could plug that 3 right back into here. You guys can see this. I do 5 times 3 plus 9. There it is. And you get 24. So that checks. This answer checks. You could check it if you want. Alright. I'm going to do one more, and then you're going to have a couple U tries. So we have a couple operations going on. We have a fraction here, or x is being divided by 2, and then it's 5 is being added to it. And that equals 11. So first thing I should do, I got to get rid of that addition and subtraction. I want to undo that addition by subtraction. Whatever I do to this side, I do to the other side. So I'm left with x over 2, because that cancels. Plus 5 and minus 5 go away. Alright? And 11 minus 5, so that equals 6. Okay, now x isn't by itself anymore. It's being divided by 2. So I'm going to multiply by 2 on both sides. Put it in parentheses, or you don't have to. So these 2's cancel. 2 on the top, 2 on the bottom cancels, and I'm just left with x, which is what I want. 6 times 2 is 12. We plug that in there, we're going to get an answer of 11. So 12 over 2 is 6. 6 plus 5 is 11. So that answer checks. Alright, you got a couple U tries. Pause the video. Alright, our last example. Whoops, let's get that down here. So there will be times when we need to make sure we combine like terms. Maybe that's better. Like terms before we can solve. So like terms. Remember what like terms are. So like terms are things like x's, if they're the same. It has to be the same variable. Let's write this out. Like terms are same variable. Whoops. Get it on the screen there. Like terms are same variable, but they're also the same exponent. Okay? So, let's look at here. 7x minus 4x equals 21. Well, this is the same variable, and it's the same exponent. Both of those exponents are 1. So, these are like terms. What's 7x minus 4x? It's 3x. If I have 7 x's and you take away 4 of them, I'm left with 3. And that equals 21. So all I did was combine like terms. Okay, now 3 is being multiplied by x, so I undo that by dividing by 3 on both sides. This cancels. X equals 7. 21 divided by 3 is 7. And you could double check that if you want. You can plug that in there and it's going to equal 21. So, a couple U tries. Alright, you guys are watching this in class, I know, so you're going to stop the video, pause, do those U tries, and then please make sure you do this at the end of the your notes here. After watching this video, what can you do? Are you good with like terms or multiplying or dividing, things like that? What don't you know how to do? And then I want you to circle if you need help. What are you going to do? Are you going to rewatch the video? Maybe you're going to ask a question in class. Maybe you're going to do both of those, okay? And maybe you're going to schedule an appointment for intervention. So I want you to see what you're going to do here. All right? Have a good day.